What's up guys, this is Sharmin here. I'm from EducatorSharmin YouTube channel, Facebook page, Instagram and Twitter I have, so you can follow me there. So in this video I'm going to teach you physics chapter 5, that is the state of matter and pressure. What is pressure? So pressure is defined to be the amount of force exerted per area. So pressure depends on pressure depends on the area through which force is applied. So here you can see this is area and this is a force and this is another type of force, this is another type of force. So if your applied force is F, okay, so area of your pump is A, okay, here is A, then the pressure. So your formula, that is it will be P equal to, this is your pressure, right? It divide, so F, that is the force, divided by area A. So this is our formula, pressure formula. So pressure, so P equal to, here is a given, that is P equal to F divided by A. So P, that is the pressure, F force, A, here is the area. So unit of pressure, that is N divided by m square. N, that is the Newton, and m square, and you can write also Pascal, that is the PA. All right. So let us suppose you want to determine the pressure of the liquid at depth h. Here this is h. So imagine an area A. So here is a figure given. The weight of column of liquid above this area, also area exert a force on A. So volume of the liquid over a surface area, that is A, that is is AH. If the density of liquid, that is the rho, so you write like this, then weight of this liquid or force is F equal to mg. So m, here is a m, that is AH rho g. Therefore, so here is a pressure P equal to, so here is a given that, what is a good picture? This is a good picture, guys. So if density of the liquid is rho, then weight of this liquid or force, that is F equal to mg. So this is a h, this is a height, and this is a area. So this is the formula we can apply for. So P equal to F divided by A, we already know that. So F, we know that F, that is the AH rho G divided by A. So if I cross A and A, so we got that H rho G. So in a liquid of fixed density, pressure rises with the increase of depth. In case of water, approximately for a 10-meter increase in depth, the pressure increases by an amount equal to the air pressure, that is the atmospheric pressure. So density can be increased by compressing air or gas by increasing pressure, but same is not true for liquids. So liquids cannot be compressed in the same way with pressure. So its density cannot be increased or decreased. So how pressure of water is increases when we go from the surface to the bottom of a sea. So I'm going to show you one diagram. So here is a diagram, that is the here is a depth kilometer, 1 2 3 4 5 6 kilometer, and water pressure, that is atom. So here 100 200 300. So pressure increases with the increase of depth. Whenever its depth is increased, its pressure also increase, like this. So this graph is shown like this. What depth of the liquid kerosene and water, mercury, kerosene, water and mercury pressure will be one atom. So we know for mercury pressure is a one atom at a depth 76 centimeter, density of water that is 13.6 times less than mercury. Therefore depth of water will be 13.6 times more. So before depth for water, that is 76 centimeter times 13.6. So if I, here is a 76. So one atom at a depth, that is the 76 centimeter, that is the depth. So 13.6, that is the depth of, so if I multiply, that is 13.6 water, that is the density of water, 13.6 times less than mercury. So it will be 10.34 centimeter. Density of kerosene, that is the 0.8 times less than water. So therefore depth for kerosene, it will be 1.25 times more. So therefore depth for kerosene, it will be, and that is here already we got the answer, right? That is the water depth of water, and this is the depth of water, but we need to figure out kerosene. So kerosene, that is the 1.25 times more, so we just multiply, so 12.92 meter. That is our answer. What is density? So what do you mean by density? The density of a substance is the mass per unit volume. What do you mean by that? That means the density is the amount of mass per unit volume. So I will give you more details about that. That is the density. If mass of a body is if mass of a body, that is the m, then we can write volume v, then density, that is the rho, equal to m divided by v. An unit of density, that is the kilogram per meter cube or gram per cc. So here the more mass in a given volume, the greater the density. Density has, that is the symbol rho, you just write like this. All right, whenever you need to figure out density any substance, so you just use this formula, that is the density of a substance, that is the mass per unit volume. Here is a one math problem, physics math problem, that is 0.25 kilogram salt is dissolved in 1 kilogram water, so that the total volume becomes, that is 1200 cc. So what is the density of this water? So what we need to figure out? We need to figure out density of this water. So how will figure out? First we need to figure out what is given here. So we know that that is the density. Density is the amount of mass per unit volume. So here is a mass, that is the m, 0.25 kilogram salt, that is dissolved in how much water here? That is the mass 1 kilogram. So we need to add here, that is we need to show here 1 kilogram and 0.25 kilogram salt. Here is a salt and water, that is the mass, and also total volume become, here is a, that is 1200 cc, that is the total volume becomes 1200 cc, that is given here. So we will write here. So here we know that that is the already given here, and 1 cc equal to 1 cube centimeter, and 1, that is we can write 1 cc equal to 10 to the power minus 2 meter cube. So if we will change it like this, then it will be, so whatever we got here, we just put it here and calculate, and we got the answer. So let's do it. So everything we have written here, so now we'll calculate, or you just use calculator and get the answer. So guys, this is our answer, 1.04 kilogram per meter cube. This is the density of this water. So guys, I hope that's all for today. Thank you for watching, and see you soon with another new video. Keep watching and keep practicing, and good luck your physics test. Thank you so much, guys.